This is ITT 216 Enterprise Route and Switch, the final assignment. This is the executive report, PowerPoint, and presentation. This is the original network. There were 2 remote offices and a main office. Since then, we've gone through a lot of changes. This is the current network. We have added 5 new locations. The new locations have wireless and switch networks. They had security added with VPNs for each new location. Internal routing protocols and specialized services were added. There are additional components and features added to the network that will be discussed throughout this report. The network is configured in a star topology, which is the most widely used topology, and is very stable. Each of the 5 new locations has a router, a switch, PC, a laptop, and a wireless switch, or a wireless adapter. The network has scalability built into it. Routers and switches have expandability in them. A 2811 router was added to provide VPN connection for the 5 new locations to the main office. The purpose of the PC in each of the locations is to provide a hardwired connection. The hardwired connection is potentially faster than the wireless connection, but it also serves as a connection if the wireless goes down. Conversely, the wireless is connected to the laptop. It can be a backup if the wired connection is needed, in addition to providing mobility for each location. In addition to the 2811 router that the new locations will connect to, each location has a 1941 router that will allow each location to connect to the virtual private network. The new routers needed to have operational systems upgraded, which was done. The original routers will remain with the network, and if needed, can be used in the future. The new locations are not the only places that have changes and growth. The main office had made some adjustments and has some new additions. There are 2 new servers added. The original 2 servers were connected for DHCP duties. One of the new servers has been set up as a DNS or domain name server, and the other is for web traffic as a dedicated server. This last addition should isolate web traffic from the rest of the network. The domain name address was set and tested, and all the components that are in the network are turned as no shut condition, which means they do not shut down as long as they have power running to them. The 2 remote offices are essentially unchanged. Hardware is fine, but if it's not configured right and running the correct software, it does not do the company much good. As the company grew, it was necessary to divide the local area networks into smaller local area networks. This is done virtually, and it is called a VLAN. The current VLANs separate the individual sections of the company so that they don't bleed over. The current ones are 1 is default, 10 is sales, 15 is engineering, 25 is main Wi-Fi, 30 is manufacturing, and 35 is manufacturing Wi-Fi. There are also pre-established VLANs that are already on the switches. All the VLANs are configured on layer 2 switches. This allows them to communicate internally within the VLAN. To be able to communicate with the rest of the network, they need to have 3-layer switches or routers, both of which are on this network. Another big protocol in the network is the NAT, or the Network Address Translation Protocol. NAT is important because it is one of the main reasons that we can still get on the internet. There are only 4 billion unique IPv4 addresses. Now this sounds like a lot until you think about all the computers, phones, and other components, gadgets worldwide. There's another type of address called an IPv6, which is the newer one and has orders of magnitude more addresses, but the implementation is slow at best. So enter NAT. In a network, there are two kinds of addresses. Private addresses, and they are used internally, and they mean nothing to the outside of the network. Then there are the public addresses, or the ones that are used on the internet. These are the ones in short supply. NAT takes the private addresses, whether they're individual or as a group of them, and gives them a public address for use while they're sending data across the internet. When the data returns, the IP address is retranslated to the private IP address, and the data goes back to the starting point. NATs also provide a level of security. Now, it should not be the sole source of security, but since the public IP is on the public side of the network, it is challenging to hack into the private side of the network because, except through the router, they don't connect to each other. VPN, as mentioned earlier, 5 new locations are using a VPN. VPN is a virtual private network. It is virtual. It carries information in a private network on a public network. It is private. The traffic is encrypted to keep the data confidential. It is a network. It is a connection to the internet. In this case, it is a site-to-site enterprise VPN. There is an option for a service provider VPN, but if it's used, the enterprise hands over all control for their security to the ISP, and that is not something that is recommended here. The software is on the 2811 router mentioned earlier that connects to the main router. It is an always-on connection, and this makes it more or less permanent. The laptops on the network, on the 5 locations, they use remote access VPNs. The corporation needs to look to the future. Currently, the best solution for the future is the SD-WAN configuration, or software-defined wide area network. The SD-WAN configuration applies a virtual overlay to an existing wide area network, and using the SD-WAN configuration allows for centralized control of the network. A traditional wide area network is a series of smaller wide area networks that are all connected together. One of the benefits of the SD-WAN is centralized control. This allows a rapid deployment of additional sites, but without the need for on-site expertise. All that is essentially needed at the site, the new site you're adding in, is someone to plug the equipment in. The rest of the setup can be done from the home location. It is also helpful for things like software updates. The update can be put out across the network, and this eliminates any lag time in getting all the locations updated. Cost is another benefit of the SD-WAN. There is no need for expertise from every site. Everything can be monitored from the home location. Security is built into the software. The software can be set up to do the job of the hardware. So there's less need for experienced people, which translates to lower cost. There's less need for hardware, so the software can do the job, which equates to fewer costs. If there's less hardware need, then there's less need for a building, not to mention the SD-WAN is the gateway to the cloud, and the cloud is the future. Having said that, it is potentially a good idea to have some data physically stored in case of a cloud failure. Redundancy is always a good thing. Having SD-WAN is a future-proofing step that the company should look into. And that concludes this presentation.